Hello everyone. Today we're going to be talking about adding and subtracting rational expressions. So kind of doing all the different operations. We did multiplication and division yesterday. And then today we're going to be talking about addition and subtraction of those rational expressions. So obviously before we start, if you could, at the top of the page, I want you guys to give at least you try now number one a shot. Using kind of the skills that we learned yesterday, just simplifying it a little bit. And then if you remember, feel free to go ahead and try example 2. All right, pause your video now and give them a shot. All right, final answer, you actually get 6/35 for this one. And that's because when we multiply, multiplication, the simple way we simplify is a different process than addition. When we multiply, remember, basically it turns into one big fraction. It's basically just we combine the numerators, combine the denominators, and then we reduce if possible. Now, if this 3 reduced with either of these numbers, then obviously we would have done that. And this particular one, it doesn't. Let's say we had a problem where it was like 4 over 5 times, I don't know, 10 over 8, something along those lines. Now this, on the other hand, this is something that would simplify. Because if we combine that as one big fraction, 4 divided by 8 reduces to 1/2, and 10 divided by 5 reduces into 10 divided by 5 ends up being 2/1. And then 2 divided by 2 cancels, so that our final answer would be 1. So if multiplication is usually the one that we like, I always tackle addition and subtraction second because this process isn't as easy. You can't just take 3/5 plus 2/7, add the numerators, add the denominators. The answer is not 5/12. And you could, if you, it's a simple enough just to type that into your calculator and know that that's not the correct answer. That's because when you work with fractions, remember 3/5 really kind of means if we have a pie that's divided into, oh God, 1, 2, 3, 4, 5. Pretend those are all equal. But if I had 3 of those slices filled in, we're technically adding that to, oh boy, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. You guys know get the drift. But if we colored in, let's make this one piece. Colored in 1, 2 of those. It's not as easy to add fractions because these pie slices are not the same size, which is not evident in my drawing. This is why I don't draw things. But we want to simplify expressions that are being added. There's a process that we have to go through involving getting a common denominator. So to get that common denominator, just so you guys know, I'll almost always simplify or write down, I'll shorten common denominator, and I'll write it as CD, just so you guys know for this. But if you're going to simplify fractions, let's start with the first one. But simplifying is exactly like what it says at the top. It means we want to combine it into one specific fraction. So in order to do that, the common denominator is how we go about doing that. So being able to identify what the common denominator is a really useful skill. One second. All right, I'm back. Sorry about that. Okay, so we want to find the common denominator. So sometimes it's as easy as you already have one. And example 1 is the perfect example of that. So if we look at those denominators, they both have a common denominator of 7. So there's not a whole lot of work to do. Once you have a common denominator, then the next step is we basically add or subtract the numerators together just like we would normally. And the denominator stays the same. If I have 3/7, then I'm adding 2/7 to that. The final answer for that is going to end up being 5/7. Adding and subtracting doesn't change your denominator. Now, sometimes you might have to change the denominator in order to add and subtract, because you can't add and subtract numerators that don't have the same denominator. But now we could check it out though. Like example 2, this one, first step is going to be if I'm adding, as soon as I see I'm adding fractions, we are not in multiplication and division world anymore. I can't just combine those as 1, multiply, and go from there. So we have to first find that common denominator. Now we would typically look to see what's here. Now these are already the same, so my common denominator is actually going to be 7x. In which case, the next step is super nice. Common denominator, these basically we kind of mush together because they have that same denominator, and we are allowed to add those numerators together. So final answer, 3 plus 2 is going to end up being 5. Denominator stays as a 7x, and away we go. Basically, when we add and subtract, it's really one fancy way of getting it to be one fraction. Once it's one fraction, then we can factor, we can basically do everything we've been doing the last couple of days, and it makes our life a lot easier. So if I'm going to take 3/7 plus 2 over x, this one is a little bit different though because we don't have a common denominator. How we create that common denominator involves taking out each of the pieces from each of those individual denominators. Because we have a 7 in one of the denominators, a 7 has to be in our common denominator. And because there's an x in there, an x also has to be in our common denominator. Now, you're going to see where that comes into play in just a moment. But how we go about doing this, if 7x is my common denominator, that's the goal for what's going to be on the bottom. Now, in order for you to combine those fractions as one though, we have an intermediate step that we have to add because both of these terms right now don't have that denominator. So what we do is we multiply by what it's missing. Since this 7 is missing an x, we multiply it by x. But in fraction world, what you do to the denominator, you also have to do to the numerator. So this first fraction, we multiply by x because that's what it's missing. And what it turns into is a 3x over 7x. And we do the same thing with the second fraction. Now this is different. This one has the x part of the common denominator, but it's missing the 7. So here we're going to multiply by 7. But again, what we do to the denominator, we also have to do to the numerator. So what that one turns into, bring down the plus sign, 2 times 7 ends up being 14, and 7 times x ends up being our common denominator. Now that we have common denominators, we're right back where we were in the first two examples. Common denominator becomes our one piece, and we do what the numerator says. We take 3x plus 14, and that goes on top. Now, typically we would look to see if this factors anymore. This one doesn't, because 3x plus 14, GCF is 1, so can't simplify anything else, and that is our final answer. So let's look at one that's a little more complicated. Not like number 4, this one, they have common denominators. So if I'm going to look at my common denominator, I don't have to do any multiplying on this one. We just have to, if there's a quantity, that whole quantity has to come into play. And the nice thing is that these guys have the same denominators. So next step is we're going to make it all be one fraction. The numerator, we have a 2x, and it's going to be a minus 5. So 2x minus 5. Wow, that 2 went crazy. Let's rewrite that. All right, we're going to have a 2x minus 5. Now we would from here check to see if anything reduces. The numerator doesn't factor anymore because my GCF is just 1. Same with the denominator. So there is our final answer. Now let's look at ones that are a little more fun. Well, let's have you guys try one. I want you guys to right now try number 5. Find a common denominator and then tell me what the simplified answer would be. Go. All right, now number 5 was a little bit tricky. Not because of concept, because the nice thing about number 5 is that there already are common denominators. What's tricky about this one ends up in the simplifying step. Because if they have the same common denominator, then we can create all one fraction. On the numerator, it's going to be 13 minus. Now, this 3x minus 5, we have to keep in mind that all of that is technically grouped together. So when we combine them as one fraction, we have to imagine that there are parentheses around those pieces together. And what happens is because this problem is a subtraction problem, we're taking the first numerator minus the entire second denominator. And what happens is that we have to make sure that we distribute. because it's 13, it's not only minus 3x, but it's also minus 5. So I always kind of think about that as being like a -1 in front. And in front of any quantity, we always distribute the number that's in front. So I'm technically subtracting 3x, but I'm also subtracting 5. This is what your numerator should end up looking like. Now, from here on out, that's really the only tricky step. From here on out, we add and subtract like normal, -3x. There's no other x's on top, so that stays. Numbers-wise, I have 13 minus 5, which ends up being a +8. And then from there, we would look to see if we could factor and simplify. We can't on this one. The numerator GCF is technically -1, but that doesn't change the fact that nothing else simplifies. So that would be our final answer. Now, the trickiest problem, this is the one we're going to end with today. Not in concept, but a lot of students think this is the hardest one. Because they, first of all, look at number 6 and they say, Ms. Hardy, there aren't common denominators. And you're right. So that means we have to find our common denominator. Now, remember, addition signs group things. So if we have quantities, entire quantities can also be part of our common denominator. If the first fraction has a denominator of x plus 7, then an x plus 7 has to be in our common denominator. If an x plus 4 is in the second one, if that's in the denominator over there, then x minus 4 has to be in our common denominator. And just like before, we multiply each piece by what it's missing, even if it's a quantity. This first part of the fraction right here, because it already has the x minus 7 part, it's missing the x minus 4 part. So we are going to multiply, what is it, x minus 4. I'm going to multiply the denominator by x minus 4, but that also means we're going to multiply the numerator by x minus 4. The second part here, that one actually has the x minus 4 part. What it's missing, what it's missing is the x plus 7 part. So I'm going to multiply this guy by x plus 7, which if I multiply the denominator by x plus 7, I have to multiply the numerator by x plus 7. Now, what that does is now that our denominators are the same, x minus 4 times x plus 7, x minus 4 times x plus 7, what you have now created are fractions that are the same. The first one that we have technically, x minus 4 times x plus 7. On the top, we're going to have, and it doesn't matter what order you write those in. So if you're a fan of writing things in order, go for it. Let's say we have x plus 7 times x minus 4. On the top, it's going to be technically 3 times x minus 4. And then the second fraction, it's x plus 7 times x minus 4. And on the top, you're going to have 2 times x plus 7. Now, this step technically isn't a step that you have to write. It's more just simplifying just so you don't forget signs and things like that. But because they have that same denominator, next step is combine the fractions. Keep that common denominators, and all we do is we add or subtract the numerator. In this case, it's addition. So it's going to be, now, what I'm going to do is I'm actually going to distribute these numbers because it's an addition sign. That's not going to change the signs of these guys. So I'm going to actually go through and do this. 3 times x is going to end up being 3x. 3 times -4 is going to end up being -12. Positive 2 times x ends up being a positive 2x. And positive 2 times 7 ends up being positive 14. And what that leaves us, let's see if we can simplify anymore. We have, let's see, 3x plus 2x. That's going to simplify and end up being 5x. -12 plus 14 is going to end up being a positive 2. And because that doesn't simplify with anything that's on the bottom, now that we're one fraction, that just means this is as simplified as it gets. All right. So if you guys are done, you can now move on and you guys can start working on the practice for today. We are actually going to kind of skip 7, 8, and 9 for today, and that's actually going to be kind of like our part 2 of this. So you don't have to worry about these right now. So if you see problems like these on the homework, you can actually skip those for today. We're going to tackle that tomorrow. All right. But if you would like to, Give these two neutrinos at the bottom a shot. We are going to go over these together when we meet back together as a class. All right. But with that being said, if you have any questions, feel free to email Miss Hardy. All right.